In this tutorial, we will troubleshoot a TempDB space problem from beginning to end. The aim is not to restart SQL Server or shrink TempDB as a first reaction. Instead, we will prove whether TempDB is genuinely under pressure, identify what type of activity is using the space, find the session and application responsible, and then confirm that the pressure has been removed. This is a controlled lab, so run it only on a test SQL Server instance. When an application reports that TempDB is full, keep the investigation focused on 4 questions. First, is TempDB actually short of usable space? Second, which category is consuming it, user objects, internal SQL work, or the version store? Third, which session, login, computer, and program own that usage? Finally, what is the safest next action? These questions prevent guesswork and give you evidence for an incident update or escalation. Think of TempDB as SQL Server's shared temporary work area. Applications can create temporary tables there. SQL Server also uses it internally for operations such as sorting, hashing, and work tables. A third area, called the version store, holds older row versions used by features such as snapshot isolation. The important point is that TempDB is full is only the symptom. The bucket using the space tells you what type of problem you are investigating. This walkthrough uses 2 SQL Server Management Studio windows. Session A creates and holds the controlled TempDB workload. Session B is the monitoring and diagnostic window. After starting Session A, leave that tab open even when it shows executing. Do not run the diagnostic queries in the same tab. Open a separate query window for Session B, because closing or cancelling Session A releases the temporary table and removes the evidence we want to inspect. Run this lab only on a non-production SQL Server instance. The default target is 256 megabytes, but the procedure also contains safety limits. Stop immediately if current MB remains at 0 while inserted rows continues to rise, if a safety stop status appears, or if TempDB usage grows far beyond the target. Do not increase the target simply to make the output look more dramatic. The purpose is to create enough pressure to demonstrate the investigation, not to exhaust the server. Follow the scripts in the order shown. First, create the lab database and procedures. Second, verify that the setup completed. Third, start the workload in Session A. Fourth, monitor its progress from Session B. When the monitor reports that the target has been reached and is being held, capture the TempDB snapshot. After interpreting the results, run the cleanup script. Keeping this order matters because each later step depends on objects and evidence created earlier. Open the script named o1_setup_tempdb full_lab.sql and run the complete file on the test instance. The script removes any previous copy of the lab database, recreates it, creates the logging tables, and creates the stored procedures used later in the tutorial. Wait for the script to finish without errors. Do not copy only the visible excerpt from the slide. Execute the full packaged SQL file so that every required object is created. The setup creates the support desk_tempdb full lab database, a lab run table, a TempDB pressure log table, and 3 stored procedures. Lab run records when a demonstration starts and who started it. TempDB pressure log records progress from the workload. The start lab run procedure creates the run identifier, start TempDB pressure creates the controlled workload, and capture TempDB snapshot returns the diagnostic result sets. The later slides assume all of these objects exist. Now run 01a_verify_tempdb full_setup.sql. The first result should confirm that the current database is support desk_tempdb full lab. The second result should list the 2 tables and the 3 stored procedures created by setup. If any object is missing, stop here and rerun the full setup script. Do not start Session A until this checkpoint passes, because the workload and diagnostic scripts depend on these objects. In a new SSMS query window, open o2_run_tempdb_pressure_session_a.sql and run it. This window is Session A. The procedure aims for 256 megabytes, inserts rows in batches of 1000, and then holds the temporary table for 20 minutes. Session A is only the workload generator. Once it starts, leave this tab open and move to a second query window. Do not wait in Session A for the whole procedure to finish before continuing. Session A may continue to display executing. That is expected because the procedure is building the temporary table and, after reaching the target, deliberately waits while keeping the table alive. The diagnostic work happens in Session B, not in this window. Leave Session A running, open a new query tab, and use that second tab to monitor progress. Cancelling Session A too early removes the temporary table and ends the demonstration. The lab measures the reserved pages belonging to its own temporary table and converts those pages to megabytes. This value is written to the pressure log as current MB. During a healthy run, current MB should move upward toward target MB as rows are inserted. This is more useful than simply counting rows, because TempDB pressure is measured in allocated space. If rows increase but current MB remains 0, treat that as a measurement failure and stop the workload. Open 02a_monitor_pressure_from_session_b.sql in the second SSMS window and run it. This query reads the latest pressure log entries, with the newest row at the top. Run it again periodically while session A is active. You are not trying to make session A return results, you are watching its progress from session B. The columns show the workload session, target size, measured size, inserted rows, current status, and a plain English note. Read the newest row first. Session ID identifies the workload connection in session A. Target MB is the intended size, and current MB is the measured size of the lab temporary table. Inserted rows confirms that the workload is progressing. Status text is the decision column. Building_pressure means wait and rerun the monitor. Target_reached_holding means the workload is ready and session A is holding the evidence open. Only move to the snapshot step when that ready status appears. The monitor also tells you when to stop. If current MB remains 0 while inserted rows increases, the measurement is not working and the workload may continue unnecessarily. If status text begins with safety_stop, do not proceed to diagnosis, cancel session and cleanup. If current MB greatly exceeds target MB, stop the workload rather than allowing TempDB to continue growing. An executing message by itself is normal, but a bad monitor status is not. Capture the diagnostic snapshot only after the newest monitor row shows target_reached_holding. At that point, session A has reached the intended pressure level and is keeping the temporary table open. If the status still says building_pressure, wait and monitor again. If a safety stop status appears, end the lab instead. Keep session A open while capturing the snapshot, because closing it releases the temporary object and changes the evidence. In session B, run 03a_capture_tempdb_snapshot.sql. This executes dbo.usp_capture tempdb snapshot and returns several result grids. Each grid answers a different support question, so do not treat the output as one large table. Start with the result set map, then inspect the space buckets, pressure log, session consumers, files, disk capacity, running requests, version store, and old transactions. The next slides explain what each result means. The first grid is a map of the remaining outputs. It tells you the question each result set answers, what column to inspect, what the finding means, and what to do next. For a quick investigation, read result set 01 first to identify the type of space usage, result set 04 to confirm the lab status and session, and result set 05 to identify the owning login, host, and program. Then use the file, disk, request, and transaction results to complete the diagnosis. Use in a live environment while the TempDB problem is occurring. Sort by total_MB descending. The top row is the likely TempDB consumer. Use program_name, host_name and SQL text columns to identify the application, process and SQL statement, batch. Result set 01 shows how TempDB space is divided. Free data space is the unused space available inside the existing TempDB data files. User object space is used by temporary tables and similar objects. Internal object space is SQL Server's work area for operations such as sorts and hashes. Version store space contains older row versions. Start by checking whether free space is low, then compare the 3 used space columns to see which bucket is driving the pressure. For this lab, user object space should be the main bucket because session A creates a temporary table. Version store and internal object usage should normally remain comparatively low. In a real incident, a different largest bucket changes the investigation. High user object usage points toward temporary tables or application code. High internal object usage points toward expensive query operations. High version store usage points toward row versioning and transactions that may be preventing cleanup. Result set 04 shows the latest pressure log records created by session A. Read the newest row. Session ID is the connection that owns the lab workload. Current MB shows its measured progress, and status text tells you whether it is still building, holding at the target, or stopped by a safety condition. For this demonstration, the expected ready state is target_reached_holding. Record the session ID because you will compare it with the consumer result next. Result set 05 lists sessions that currently own TempDB user object or internal object space. The list is ordered by total_net_MB, so the largest consumer should appear at the top. The row includes the session ID, SQL login, host computer, program name, user object megabytes, internal object megabytes, and total megabytes. In this lab, the top session should match the session AID and should identify SSMS as the program. The consumer row connects the TempDB usage to an owner. In the lab, confirm that the session ID matches the pressure log and that the program is Microsoft SQL Server Management Studio. In a live incident, record the session ID, login, hostname, program name, and total TempDB megabytes. This information helps determine whether the source is an application server, report, SQL agent job, support query, or user session. Do not kill a production session based on this row alone. First confirm its business impact and current activity. Result set 02 shows the TempDB files themselves. Focus on the data files, their current size, maximum size, growth setting, and physical path. A file marked no_growth, a restrictive maximum size, or an unsuitable growth setting can prevent TempDB from obtaining more space. Multiple data files are not automatically a problem. The purpose of this grid is to confirm whether the configured files are capable of growing when more space is required. Result set 03 checks the Windows volume underneath each TempDB file. The key column is available_GB. If several TempDB files are on the same drive, the same volume figures may appear repeatedly. You only need to interpret the underlying drive once. Low available space can block file growth even when SQL Server is configured to grow. In this lab, the drive should have sufficient free space, so disk capacity should not be the cause. Result set 06 shows requests that are actively executing at the moment of the snapshot. Match the suspect session ID from result set 05 if it appears here, then inspect its command, database, wait type, elapsed time, and statement text. SQL Server background workers such as log writer or lazy writer are usually noise for this investigation. A session holding a temporary table may be waiting or sleeping and may not appear as an active request, so absence from this grid does not clear the session identified in result set 05. The version store result shows whether row versions are consuming meaningful TempDB space. The old transactions result shows transactions that have remained open for a long time. High version store usage combined with an old transaction can indicate that cleanup is being held back. In this lab, version store usage should be low because the demonstration uses a temporary table. In production, investigate the application and owner before ending any transaction because rollback can be disruptive and may take time. Now combine the evidence into a concise support conclusion. State whether TempDB was genuinely under pressure, identify the largest bucket, name the session, login, host, and program responsible, and note whether file growth or disk capacity contributed. For the lab, the conclusion should say that a controlled SSMS session created user object pressure, the disk had capacity, and the known session a connection was the consumer. In a real incident, use the same structure with the actual evidence. Use the largest bucket to choose the next action. High user object usage means investigate temporary tables and the owning session or application. High internal object usage means look for expensive queries, sorts, hashes, spills, and reporting workloads. High version store usage means investigate long-running transactions and row versioning activity. Low disk space or blocked file growth requires a storage or configuration response. Preserve the evidence before canceling a session, restarting a service, or changing TempDB files. When the investigation is complete, cancel session A if it is still holding the workload, then run 04_cleanup_tempdb full_lab.sql. The script drops the lab database and returns a final TempDB space summary. The local temporary table is also released when session A ends. Run cleanup only after you have captured the evidence you need, because ending session A changes the TempDB usage and removes the controlled consumer. After cleanup, confirm that user object space has fallen and free space has increased. This proves that the temporary workload was responsible for the pressure and that ending it released the allocation. Do not panic if the physical TempDB files remain at their larger size. SQL Server commonly keeps the files allocated for reuse. Free space inside the files is what matters here. The recovery check is about usable internal space, not automatically shrinking the files on disk. After cleanup, confirm that user object space has fallen and free space has increased. This proves that the temporary where the complete runbook is. Confirm the problem, identify the largest TempDB bucket, find the owning session and program, check file growth and disk capacity, inspect current requests and transactions, choose the safe action, and then confirm recovery. In a live environment, record the evidence before making a disruptive change. The goal is to replace TempDB is full with a clear statement of what used the space, who owned it, and what action resolved or escalated the issue. RK-load was responsible for the pressure and that ending it released the allocation. Do not panic if the physical TempDB files remain at their larger size. SQL Server commonly keeps the files allocated for reuse. Free space inside the files is what matters here. The recovery check is about usable internal space, not automatically shrinking the files on disk.